We're going to practice now with multiple examples of using the different rules of derivatives that we have learned. So we just learned the chain rule, and we even know the product rule and the quotient rule. And so looking at the example, y equals 1 all over the quantity 3x squared minus 4, and that quantity is raised to the 5th power, and we want to find the derivative. So looking at this, there's a couple ways that we can approach it. We can distribute out 3x squared minus 4 5 times in the denominator and use the quotient rule. We could use the quotient rule, and within the quotient rule, we can use the chain rule. Or we could rewrite this. And so notice that we can rewrite this by moving that whole parentheses up into the numerator and changing the sign on our exponent of that parentheses. So I could rewrite this as y equals 3x squared minus 4 all raised to the negative 5th power. That to me would be a lot easier than going through and using that quotient rule. And so now we can use the chain rule. So dy dx, and we can think of this using it as like the general power rule. So our outer function is this parentheses raised to the negative 5th power. So if we bring down our power down front, negative 5, take what's inside our parentheses, which is the inner function 3x squared minus 4, and then we subtract 1 from our exponent. So negative 5 minus 1 is negative 6 times the derivative of the inside. So times d dx of the inside function, which is 3x squared minus 4. So let's rewrite this. So this is equal to negative 5, parentheses 3x squared minus 4, raised to the negative 6th power. And now the derivative of 3x squared minus 4. So the derivative of 3x squared, bring our power down front, 2 times 3 gives us 6. Subtract x and subtract 1 from our power, it's just left with a 1, and the derivative of constant is 0. So let's multiply this negative 5 times this positive 6x, which gives us negative 30x. And at the same time, let's bring down this parentheses with a negative exponent to change the sign and make that exponent positive. So we can bring down the whole piece with a negative 6 exponent, which is the parentheses 3x squared minus 4. And now it's raised to the 6th power. So we found the derivative using the chain rule, but first we had to manipulate that so that we could use that chain rule right there and not the quotient rule. Let's look at another example. Unless there's questions, stop me. Okay, so we have the following. P of t is equal to 3t plus 2. This is cubed all over 4t squared minus 1. And so you need to figure out how you would approach finding that derivative of p of t. So find p prime of t. So how it's written right now, we would have to use the quotient rule. And within that quotient rule, I noticed the numerator, we'd have to use the chain rule. So we need...
Professor?
Yeah.
Do you think I can see the last example for a couple, just maybe another minute?
Of course you can. Hold on, let me pause. Okay, so we're looking at what we need, and we're going to be needing the quotient rule. And then look at within this quotient rule, when we took the derivative of the numerator, we're going to need the chain rule. So if we do it that way, the derivative of P of t is equal to, so I'm going to just write down what I'm taking the derivative of. I'm not going to take the derivative of it until the next step. So quotient rule says the derivative of the numerator, so d dx of the numerator, which actually it's not x, right? We're in a variable t, so I would write this as d dt is 3t plus 2 quantity cubed times, it says the denominator. So we need parentheses around that whole denominator because there's more than one term. So 4t squared minus 1 minus the numerator, which was the 3t plus 2 quantity cubed times the derivative of the denominator. So I'm going to write it as d dt, derivative of the denominator. So parentheses around 4t squared minus 1. And we put this all over the denominator and we square it. So that's just the rule derivative of the quotient rule. So now we can go put it together. So now looking at this, it says take the derivative of this 3t plus 2 cubed. I need the chain rule there. So this would be saying 3, bringing my power down front of the inside, 3t plus 2, subtract 1 from my exponent. So subtracting 1 from that 3 gives me a squared. But we need to be careful because we still need to take the derivative of the inside. So I'm just going to right now put down that I'm going to. So d dt of the inside, 3t plus 2. Times the denominator, which was that parentheses 4t squared minus 1, minus this 3t plus 2 cubed. Now let's take the derivative of the denominator. So taking the derivative of 4t squared, bringing our power down front, 2 times 4 is 8. T, subtract 1 from our power is just 1. Derivative of constant is 0, all over the denominator, 4t squared plus minus 1, that quantity is squared. Okay, so we want to clean it up some more. Let's go in. We still haven't taken the derivative of the inside yet. I cannot distribute this 3 inside the parentheses because this is a square here. I could technically plug it or distribute it here, but let's leave it alone for now. So I have this 3, I have this 3t plus 2 quantity squared. Now the derivative of this inside piece, let me change the color. We take the derivative of that inside piece, derivative of 3t is just 3, and the derivative of a constant is 0, times the 4t squared minus 1, minus, I'm just going to bring that 8t out front. So 8t all times 3t plus 2 quantity cubed, all over 4t squared minus 1 quantity squared. Okay, so I want to manipulate this a little bit. And again, further on in this course, we're going to be finding out when these values equal 0 or where it's undefined. And so having the numerator factored or simplified is really helpful to when we're going to be doing that. So let's first multiply this 3 times this 3, and that's 9. So we have the 9 out here. I'm going to keep in color our parentheses 3t plus 2 squared. And then I have, and I'll show you why in a minute, this parentheses 4t squared minus 1 minus 8t. But this time, notice I have a 3t plus 2 over here, quantity cubed. So I'm going to write that as 3t plus 2 quantity cubed in a different color, all over 4t squared minus 1 quantity squared. So I could expand that all out, distribute, combine like terms, see if I can factor it that way. But that would be a lot harder than noticing. So think of this as two separate groupings, because these are all products here. This 9 times this quantity 3t plus 2 quantity squared times 4t squared minus 1. Think of that as one grouping. And think of this 8t times the 3t plus 2 quantity cubed as one grouping. And notice what they have in common and pull that out. So first thing I would look at is, do my numbers have anything in common? Does 9 and 8 have anything in common? And they don't. But I notice that 3t plus 2 quantity squared and 3t plus 2 quantity cubed have 2 of those in common. So we can pull out a 3t plus 2. We're pulling out the most they have in common, and the most they both have in common is 2 of them. So if I pulled that out of the first grouping, it no longer would be there. I would just have that 9. And I would also have this parentheses 4t squared minus 1. And then minus, if I pulled that out of the second grouping here, and I pulled out 2 of these. And so that means that I'm going to be left with 1 of them. And so I have this minus the second grouping. I'm left with the 8t. And I'm left with 1 of the 3t plus 2s. All over 4t squared minus 1 quantity squared. So I want to, again, clean this up a little bit. We can distribute. So I notice I can distribute my 9 inside that second parentheses and that 9 inside the bracket. And I can distribute, and I want to carry the sign because I would rather do it now than having to do it twice. Distributing, so let's distribute negative 8t to both terms in here. So we're left with, out front, this 3t plus 2 quantity squared. And then we have 9 times 4t, which is 9 times 4t squared, which is 36t squared. Nine times negative 1, that gives me minus 9. And then let's distribute the negative 8t to the 3t, that gives me minus 24t squared. And negative 8t times this 2 gives me minus 16t. This is all over 4t squared minus 1 quantity squared. And as we have like terms in that parentheses, one of the parentheses in the numerator. So we still have that 3t plus 2 quantity squared. In that second parentheses, let's combine like terms. So we have a 36t squared minus a 24t squared. That's going to give me 12t squared. There's no other term with just a t besides that minus 16t, so bring it down and bring down our minus 9. All over 4t squared minus 1 quantity squared. I would only do this, I might want to check to see if 12t squared minus 16t minus 9 can be factorable. Only the time I would really kind of want that is if that canceled with one of my factors in the denominators, and it would not. So I probably would not factor this right now unless I was trying to find when this was equal to 0. So let's just leave it like that unless you guys want to look at it and see if it's even factorable. So the next example, we want to find the derivative of r of t. R of t is defined as 4t times the quantity 2t to the 5th plus 3, and then that quantity is raised to the 4th power. And so think about what rules you need to apply when doing this. I notice that I can think of this as a product. I can think of the first function as 4t, and I can think of the second function as this parentheses raised to the 4th power. So I'm going to need to use the product rule. And within that product rule, I notice that I'm going to need to use the chain rule. So let's just write out how to do that. So r prime of t. So if I was using the product rule, that was the derivative of the first. So I have d dt of the first function, 4t, which is not bad, times the second. So the second one, I'm not doing anything to it. It's 2t to the 5th plus 3, all raised to the 4th, plus the first, not doing anything to it, 4t, times the derivative, so d dt of the second piece, which is 2t to the 5th plus 3, all raised to the 4th. So going in and taking the derivative of 4t, well, the derivative of 4t is just 4 of the second piece, so 2t to the 5th plus 3, all raised to the 4th, then plus the 4t. Now the derivative of this second piece, so I need to use the chain rule here. So let's use the general power rule where we're bringing down the power down front, the outer function of the inner, 2t to the 5th plus 3, subtract 1 from our exponent, so 4 minus 1 is 3, times the derivative of this inside, so times d dt of the inside, 2t to the 5th plus 3. So I can't bringing things down. I cannot distribute the 4 inside the parentheses again because the exponent is not 1. So I'm going to leave it alone. So 4 2t to the 5th plus 3 raised to the 4th. Let's see. Notice here I have a 4t times a 4. So I can rewrite this as plus 16t of the parentheses 2t to the 5th plus 3 cubed times the derivative of 2t to the 5th plus 3. So bring our power down front, 5 times that 2 is 10. T, subtract 1 from our power, it's a 4 power. Derivative of that constant is 0. So we have 4. Notice that we have in parentheses this 2t to the 5th plus 3 and this 2t to the 5th plus 3. So I notice that I'm going to be able to factor that out in a little bit. I'm going to be able to factor out 3 of them. Oops. Okay, so I have that 4. So maybe let's write that in a different color for now. And so this is 2t to the 5th plus 3 raised to the 4th power plus, just rewriting things for this second grouping, I have a 16t times a 10t to the fourth. Well, 16 times 10 is 160. And using rules of exponents, t times t to the fourth, add our exponents, we get t to the fifth power. All times that parentheses 2t to the fifth plus 3 cubed. So again, we're going to be using this where we're going to have to find where these are equal to 0. So you might as well get the practice right now. So notice what's inside of the parentheses, we have the same, and think of those as two separate groupings. So we have one grouping here, plus in between, and then we have the second grouping. So we want to pull out what they have in common. So I first look at my coefficients, 4 and 160. So I notice 4 and 160, 4 is divisible in both, so we can pull out a 4. And then I notice that I have 2t to the fifth plus 3 raised to the fourth, and 2t to the fifth power plus 3 cubed. And so we want to pull out 3 of those. So pull out the parentheses, 2t to the fifth plus 3, and we're pulling out 3 of them. So if I look at what would be left if I pulled out a 4 and the 2t plus 5 to the fifth power plus 3 cubed from this, and we left with 2t to the fifth plus 3 for that first grouping. Plus, and now if I pull out a 4 from 160, well, 4 times 40 will give me 160. So that would be a 40. I didn't pull out any t's, so I still have that t to the fifth. And I pulled out 3 of these parentheses, which is what that was. So I don't have any left. I can think of it as a 1 left. So in my parentheses. So notice inside that second parentheses, we can combine a couple like terms. So we have 2t to the fifth plus 3 quantity cubed, all times, well, 2t to the fifth plus 40t to the fifth is 42t to the fifth, and then plus that 3. So we just found the derivative using the product and chain rule.